So screen candidate resource no என்ன sir?
Candidate
Candidate.
um, number of sites.
Okay.
Candidate is nothing. Suppose they are giving you three or four places, Theni, Kambam, Madurai, and all that. These techniques can be used to screen whether Theni is better, Madurai is better, or Kambam is better. Candidate is nothing but uh, the proposed sites. Okay, is it clear?
Yes sir.
The proposed sites, candidate resource areas
Okay.
for with high potential of wind energy to estimate wind energy characteristics. One is through numerical modeling, as I told you. Uh,
Yeah.
that is from the global weather model. You bring down to by putting topographics inside. You can bring down to the local level and then find out how the wind is flowing over the terrain. If there are hills, trees, paddy fields, plain ground, and all that. Okay, that is by numerical modeling. Second is through wind tunnel and water tunnel. Okay, then topographic indicators are the kind of tree pattern, tree bending patterns, or some other biological factors. Then geomorphical indicators, sand dune formations, or all grasses on one side, and things like that. Okay. Then social and cultural indicators. For instance, in India and Tamil Nadu,
So 1 minute sir. 1 minute sir. So
uh,
biological means in that
uh,
category what all it will come sir?
biological means there will be bird nests in some areas.
But
Bird nests. No, they
okay
will
okay.
build the nest depending on um, that the nest should not be damaged and all that.
Okay okay okay.
So even tree is a kind of a biological indicator. Paddy field is also
Topographical means
topographical means hills,
hills.
uh, hills, valleys, and how they are located, how the patterns of wind damages are. Okay, in a particular, suppose there is a steel painted surface,
Mm.
depending on the wind damage pattern in the painted surface. These
Mm.
are all
Okay.
topographical indicators.
Okay. So rest everything will come under biological.
Yeah, geomorphological, biological, and
Okay.
social cultural means people will orient. In southern Tamil Nadu, if you go தெக்க பார்த்து வீடு இருந்தால் நல்லா இருக்கும்பாங்க. Reason என்னன்னா
Okay.
most of our wind in Madras, our own measurement in Tidal Park, more than 1 year we have measured wind velocity.
Ah.
In Chennai, the most prominent wind direction is southeast.
Okay.
That segment, south, southwest, southeast. That
Mm.
segment is the most predominant direction of wind. So
Mm.
we will orient the wind main entrance towards that, so that there will be wind flow, good wind flow inside the house.
Okay.
These are all social and cultural indicators. Okay,
Mm. Okay.
and synoptic scale is kind of a meteorological model which will run into thousands of meters, about 620 miles. It is like how the meteorologists predict. There is a upper
Mm.
area movement 400 kilometers away. There is a storm. There is a cyclic vortex rotation. There is a upper air circulation.
Mm.
These things will happen in big diameter bubbles,
Mm.
1,000 kilometer bubbles, and things like that.
Mm.
Those changes will be very slow, so it will not be immediate.
Mm.
Suppose a cyclone forms in the Andaman coast, to reach Chennai, it will take 3-4 days. Those meteorological changes in that scale will be very small, very slow. It will not be abrupt. Fluctuations
Mm.
will not be there. Okay.
Mm.
Then we come to mesoscale. This is the wind pattern within, say, 5 kilometers or several hundred kilometers within
Mm.
your Tamil Nadu state, within a Madurai district, and so on. Okay. Then micro is 1 kilometer or less. That is very close. We will
Okay.
use for wind resource analysis, mesoscale and microscale. We may derive long-term um, parameters from synoptic scale.
Okay.
That is meteorological weather models. Okay, global
Okay.
weather models. Okay, right. Essential requirements. Yeah. There are essential requirements for any wind farm development is high wind resources at a particular site. You agree with me? Okay,
Yes, sir.
and then adequate land availability. I mean, land availability means you should be able to get the land even though it is available with other people. Okay, adequate land availability. Then suitable terrain and good soil conditions. It should not be a sinking clay soil. Now, even in sinking clay soil, we can do foundations. Good soil conditions means you'll be able to economically build the tower and foundation. Okay.
Mm.
Then proper approach to the site. See, even though it is in a quarry which is abandoned in a hill, okay, there should be an approach to the site. Then you can select it. In Maharashtra, Dhule region, if you go, wind farms will be located on the ridges of the uh, long ridges of a small outcrop in the terrain, because all other areas are agricultural fields. You don't get permission in Maharashtra,
Okay.
Dhule area. Okay.
Mm. Where
Similarly,
it will be, sir? Where it will be in Dule?
in they will only allow mountain ridges which are not having agricultural usage.
Okay.
You won't get other lands very easily. Okay.
Mm.
Then suitable power grid supply, reliable power purchaser. Yeah. In any case, in our case, majority of the power purchase is done by the utility, state utilities. Okay.
Okay.
Then techno-economic selection of wind electric generator. Techno-economic selection means you have to map both wind resource as well as the wind machine. Then only you will get optimum generation. Okay, we will
Mm.
see that in the technology part.
Okay.
Okay, then O&M needs. What is the O&M need? If it is very close to the shore, seashore, a lot of corrosion may be there. You may have to paint it quite often. All those things. O&M needs. Okay, uh,
Mm.
you may have to clean the wind blade quite often. If it's a dusty environment close to a cement plant or something. Okay, O&M needs also you should think of. Okay,
Sir, WAG is wind energy generator, no, sir?
yeah, wind
Ah.
electric generator or wind energy generator. Wind electric
Mm.
generator normally used.
Okay.
Best is WTG, wind
Ah.
turbine generator.
Same only, no, sir? Both term same
Both are
only.
same. Yeah, both are same.
Okay.
Right.
So
Then
O&M needs means only the seashore, coastal area only we need to.
no. O&M means operation maintenance.
That is okay. While
Yeah.
in taking care of the O&M needs,
uh, Easy access
uh,
to the site, easy. You should be able to take your supply chain easily if a blade has to be changed or if a gear has to be repaired. All the O&M needs, no?
yeah, yeah,
And you should
understood.
also have skilled manpower available there locally if
Mm.
possible.
Mm.
Okay, at a uh, so that if you depute a person with a high experience in a remote village, you may not stay there long.
Mm.
So we may have to locally develop some skills and O&M needs. You should look into all these aspects.
Okay.
Okay,
Mm.
right, right. Then collection of reliable wind data is essential for wind power project. And wind data includes mean wind speed, direction data, short-term variations, that is fluctuations, variations with height. All this we discussed earlier. Huh? It
Yes.
increases along the height. Okay. Then
Yeah.
daily and seasonal variations. Strong southwest summer monsoon, April to September. That is normally Normally May to September, we can say. April end it starts. Then weaker northeast winter monsoon in Tamil Nadu, especially. 1986, we started wind resource assessment in India. We started with 20-meter mass in the beginning. Only NIWE was doing. Nowadays, the companies which are developing wind farms, they are doing themselves. Okay. Uh, Now there are highly specialized wind resource assessment companies in India, more than three or four. Okay. Uh, if you interest them the job, they will do it at a turnkey basis and give you the data in your server directly. Okay. So as a IPP, you may not have your own wind sighting team. Do you have it? A wind sighting team?
I don't know, sir. Like it will be
Yeah,
differently. It will be by our central team.
a central team.
Ah,
Normally, greenfield projects are developed by Renew Power. In that case, you need to have a wind sighting team.
Here
They
I
will go.
separate team.
Yeah, they will do this all this preliminary site visit, whatever we discussed in the morning. Okay, all those they will do prospecting first,
Mm,
and then try to locate a best place, minimum number of wind masts. Each
okay.
wind mast costs a lot of money, sensors and everything, and data acquisition, large volume of data to be analyzed and all that. Okay,
Okay.
so they will do all this. The wind sighting team will start with this kind of work. First prospecting, then validation and micro sighting. Okay,
Mm,
right. In India, we started now. Now we are having measurements up to at 50-meter level all over pan India levels, 120-meter level mass, 150-meter level also we have. Okay, so based on our NIWE, National Institute of Wind Energy estimate, okay, the data which you can buy, if the data is already available with the NIWE, okay,
mm,
for every site you can buy the data completely, 1 year measurement or 2 year measurement, whatever they have, you can buy the data. Okay, and that will give you based on that data estimate, they have given at 120-meter in different states of India, what is the wind power potential available. One of the highest potential is there in Gujarat, 142 gigawatt at 120-meter, 180 gigawatt at
sir,
one.
this estimation, no, sir.
Uh,
Estimated potential
uh,
120
yeah,
meter height to 150 meter, right?
yeah, yeah.
Actually, this estimation done earlier or recently, sir?
No, it's earlier done and it is being continuously updated.
Updated.
Yeah, it is getting continuously updated. Okay, by
Mm,
NIWE.
leeway.
It's getting updated by for the NIWE sites wherever the tower is still operational.
Mm.
Okay, if they have removed the tower, no further update will be available.
Oh.
Yeah, you can check with NIWE whether particular location in that particular state data is already available, in which year it is available. You can take that information.
That
Okay,
means like
yeah,
in Gujarat,
yeah,
Karnataka,
yeah,
Maharashtra,
and Tamil Nadu
uh,
also.
Tamil Nadu also.
Yeah,
It will be
yeah,
like
Rajasthan also 127 and 184 at 150-meter.
Rajasthan.
Tamil Nadu also 68.75 and 95.107 gigawatt.
So
Uh,
lowest
Lowest will be, there are only 7 states which will have high potential in India.
mm,
About
India, yeah,
seven.
yeah.
Yeah. Maybe Andhra Pradesh, uh, uh, Gujarat, and then we'll have Madhya Pradesh, then Tamil Nadu, Karnataka, Rajasthan, Maharashtra. That's all. Okay.
Okay.
This estimate is a gross estimate for the entire state based on number of met measurements all over the state, along with uh, long-term data generated or bought from other. foreign resources.
These values are in megawatt.
Yeah, these are in megawatt. What the values are in megawatt. Okay, and which
Okay,
state,
that
which are,
black are not to be considered, only green to be considered.
yeah, green or more potential. Black,
Amount.
yeah, yeah.
Uh,
Uh,
okay.
they might have exhausted already in all those.
Okay.
Okay, right.
But Madhya Pradesh also there, no, sir?
Yeah, Madhya Pradesh also is there. Black and green, there is no distinction. Just to
Okay.
next row, to
Okay,
highlight the
okay,
next
okay.
row, it
Oh,
is
my
in different color. That's all.
God. Okay, okay. Hmm.
Okay, right. Uh, this estimate and how it is done. The background for this estimate is uh, earlier we showed that map, 50-meter map. You remember?
Yes, sir.
Uh, this is earlier done map. Yeah, these maps are without land use, land pattern being mapped into the wind resource.
Hmm.
Okay, assuming some amount of area available for wind farming based on assumption here. Okay, and these new values, which are done by NIVE after releasing the GIS based wind atlas when I was there. Okay, in
Hmm.
100-meter level, these new
Okay.
values are having a criteria for it. What are the criteria? I'll show you 1 minute. Yeah, yeah. At 150-meter level, for instance, okay, we got the land use, land cover. What is the we said it is terrain dependent, right?
Yes, sir.
It is terrain dependent. So we should
Yeah.
know what is the land use pattern and what is the land cover there. What covers the land area? Okay. So this based on that we have ranked rank one wasteland. Okay, wasteland means we can definitely use it for wind farming.
Hmm.
Okay, then rank two is cultivable land. This
Hmm.
information we got it from Geological Survey of India
Okay.
after well vetted by Bhuvan, like satellite based vetting.
Hmm.
What is cultivable land? The revenue department of every state would have done this land use land cover, else
Okay.
uh, LULC. Okay,
Ah.
that layer is mapped. Okay, so based on that rank one wasteland, we can use it fully, but we have not used it fully. Okay, 80% 80% of the land in rank one class. Okay, if it
Hmm.
is cultivable land, still we can use for wind farming. Modern wind turbines need only the foundation area. After the harvest is made, you can erect the wind turbine and then put the cables underneath. You can use the land, cultivable land as it is.
But
And if you,
only problem also it is not only erection of WTG, that
ah,
connecting EHV and 33 kV only we are facing because
yeah,
of
you are right.
conservation.
Right of way problem will come. Right of way, getting
Yeah,
the distribution evacuation line.
yeah,
That problem will come because the earlier windmills were only to 250 kilowatt and all that. Okay,
yeah,
they were able to put in 10 kV lines or 11 kV lines directly.
yeah,
It
yeah.
used to be consumed by the consumers around it.
Consumers directly.
It
Ah,
it will
okay,
not
okay.
come. It will not come to substation also earlier.
Oh,
Okay, nowadays
okay.
there is a minimum
But
requirement of
still
33
the name
kVA.
will be written also on the turbine.
Yeah,
Consumer name will be written in the turbine itself.
yeah. Consumer name will be written on the
Paper
turbine.
mills, this paper mills, textiles like that. Mm.
Yeah, that is they are owners actually. They would
Ah,
have installed for some purpose. Okay. Uh, Earlier, what they do, the textile mill owners and broilery owners, okay, then brewery owners, okay, சாராயம் காய்ச்சறாங்கல்ல
ஆமாமா புரியுது.
அந்த மாதிரி ஆளுங்க எல்லாம் those who consumed lot of energy, electrical
ம்,
energy, they invested on windmills because the every year's profit you can write off the entire capital invested into the windmill.
ம்.
That was acceleration depreciation, it is called in those days.
Mm.
That is why many people owned windmills, okay,
Mm.
to write off their profit.
Mm.
They did not bother about electricity generation at that point.
Mm.
They just installed windmills and get away from the profit by showing the capex investment. Okay. Now it
Okay.
is not so. Now people are interested in greening and carbon footprint reduction and all that. Generation is more important than the investment now. Okay.
Okay.
And rank 3 is forest land.
Mm.
Okay. In forest land, normally they don't permit. So we assume that's why minimum forest land will be used. 5% of rank 2, rank 3. With this land availability, 80% of the rank 1 wastelands, 30% of rank 2 cultivable land for wind, and 5% of the rank 3 forest land, we estimated. uh, the map also has been prepared in capacity utilization factor scale. I will come to the CEF value later on. Okay.
Okay.
uh, Minimum capacity more than 20%. In those areas only, these layers have been used, land availability layers, and then we arrived at this estimated potential. Is it clear?
No, just I'm unable to follow. So this line,
Huh?
the map has been this. This line I'm unable to follow.
Yeah,
The
let me tell
map
you.
has,
Yeah,
okay.
one is land availability,
Ah, all
and
those are understood.
yeah, in the land availability, some fraction of rank 1 wasteland, some fraction of cultivable land, 30%, 5% of the rank 3 forest land has been considered. Even in those considered land, okay, wherever wind power potential is possible to be exploited more than 20% of the capacity utilization, then only those points only has been considered.
Okay. Okay. Mm.
Okay. Suppose you install a 100 kilo, 3 megawatt machine. Okay. 3 megawatt will not generate 3 megawatt all the 24 by 7, 365 days. Okay. It will only
Okay.
generate for the 5 months, some 5 hours or 10 hours a day. Okay. At that peak. Otherwise, it will be always less than the peak. Instead of 3 megawatt, it will generate 800 kilowatt or 1 megawatt. Okay. Because of the
Okay.
variation in wind speed. Is it clear?
Yes, sir.
That actual generation by the possible maximum generation is called capacity utilization factor.
Mm.
Okay.
Okay.
We will define that CUF more in formula terms later on. Okay.
Okay. Mm.
Okay. So based on this estimate has been made. Okay. These maps can be used for you to do the wind farm siting. These maps are all published, public domain. It is available with
Available.
Nive, and wherever you want, if the data is available, you can buy from Nive, or there are nowadays wind resource people will would have put Metmast and be ready with the data, and they will sell you also directly to prospective wind farm developers. Okay, you can also buy from private Metmasts if they are able to give. Okay,
Mm.
right. Even Renew Power may have their own proprietary data, thinking that they will get new projects. By putting a Metmast, they would have already measured data and be ready with it. Some investor to come in. Okay,
Okay.
right. This is potential estimate from the map. Then what is micro survey and micro
Mm.
siting? Micro survey is going in depth into every 100-meter level. Okay. Suppose you take this region, then you zoom a particular area and find out what are the topographic level, where are the hills and valleys, what is the how the slope of the terrain is, what is the wind potential in various areas. Okay, these things can be further studied by looking at more coarse, finer details. Okay, and these are possible to be done using sophisticated softwares now, and that process is called microsighting. Microsighting addresses all the following things. One, it is a way to optimize the park layout, wind farm layout. Park layout means wind farm layout. So you can combine 3 megawatt wind turbines with 5 megawatt wind turbine. You can combine 5 megawatt wind turbines in one row, 3 megawatt wind turbines the next row, and all that, and find out, given an area, how to optimum uh, production can come from that site. That particular fine tuning of locations of the wind turbines given a area is called microsighting. Is it okay?
Okay.
Okay. In that, what are the things you are going to do? Wind measurements, number one. Then you assess the roughness and obstacles. Orography is nothing but uh, the various kind of things in the surface. Orography. Okay. Topology. We can say topology or orography. Okay. So obstacles, roughness, then wind resource estimate is done. Then turbine layout is planned theoretically. Okay. These are all done before developing your wind project. Then turbine layout is done. Then production estimate, including wake losses. I'll come to that. Wake losses. Wake losses means how one wind turbine affects the other wind turbine, because one wind turbine is in the front, other wind turbine is in the behind. Okay. So including wake losses to other wind turbine. So the production estimate has to be done, and load calculation to ensure 20-year design lifetime. Okay. Then calculate sound emission from turbines to the nearest neighbor, so that nobody gets uh, disturbed overnight, because the wind turbines work in the night also. Okay. Then create a visualization of the park. It should not be horrible to sight. And calculate shadow flickering. Shadow flickering is one. Suppose you have a house, villa type of house, very close to the wind farm. Okay. And when the sun is shining, the wind is blowing, the wind turbine blade is rotating. Okay. The shade of the blade will come on your window. Okay. Are you getting it?
Yeah, understood.
Yeah. So that shadow will be disturbing for some people. It will come and go like a bird hitting in your window. Shadow
Yeah.
flickering. So that will be objectionable. So that also should be nullified. You should not, the wind turbine should not create a shadow flickering effect for any of the residents close by. Okay. I
Mm.
think for all these things, in India, what they do is uh, they they specify set-offs. What is known as set-off? Okay.
Set up.
Yeah, set-off is uh, one time the diameter of the one time the height of the windmill plus one times the half the diameter of the rotor. Okay. When it falls, uh, it should not hit any fall, set off for falling on residences. So all these things are now slightly adjusted. The earlier they had a free approach. Now it is slightly adjusted to allow repowering. You know what is repowering, right?
Uh,
Huh?
Old visions will be removed and installed.
Yeah, old machines will be removed, and old machines were built with 5D, 7D spacing.
Mm.
5D means 5 times diameter of the rotor between the adjacent windmills. Okay. 7 times the diameter of the rotor between two rows of the windmills.
1 minute, sir. 5 times diameter of rotor.
Adjacent for the neighboring windmill. Okay.
Mm.
In the same row.
Ah.
Okay. And seven
Seven.
times the rotor 7 times the diameter of the rotor between two rows of the windmills, wind turbines in the wind
Okay.
farm. This
Okay.
was the allowed uh, spacing in Tamil Nadu earlier.
Tamil Nadu.
Yeah.
Okay.
Now they have relaxed a little bit to do a scientific microsighting using standard industry standard softwares or even computational fluid dynamics. Okay, you can show that it will not affect the neighbor's wind farm, and then keep proceeding. That notification has come just a month ago in April 2024. Okay,
Okay.
because of that we had a recent seminar. I think that video is already available in my website link.
Okay.
Okay,
Mm.
right. Right. Recommend another type, wind turbine type, turbine layout, hub height, wind sector management or measurement campaign. All these are done. All this is something that is done before the park wind farm is erected. So you can calculate the feasibility of the project. Is it clear? By doing
Yes, sir.
a rigorous microsighting. Okay. Right. It is to optimize
Mm.
production from the wind farm, analyze and reduce risks related to probability of wind or the wake effects being affecting the neighboring turbines. Okay, so this is the purpose of benefits of siting. So to do this micro siting, there are industry standard softwares already available. Okay,
Okay.
uh, even though I got trained in WASP, I am not a regular user of WASP. Okay,
Okay.
I don't have a copy of the WASP in my laptop, right? So I cannot give you finer details, hands-on sessions in WASP. Okay, I'm just
For
giving
this
you,
also separate class is there, sir. For WASP also.
yeah, WASP. Um, uh, WASP. We tried our best to launch a course in India. Okay, by Nive, but they were not allowing. Okay,
Okay.
WASP.
Why, sir?
WASP. They are so rigid. They want to train only in Denmark.
Ah.
We wanted to have a collaborative endeavor to train more people in WASP.
Mm.
uh, because it's a highly industry standard software which is available with the basic wind resource what we discussed so far. Okay,
Mm.
as well as using CFD, computational fluid dynamics based WASP. Now
Mm.
latest there's a Python based application programming interface with the WASP engineering models. All these are developments, and most of it is taking place in Denmark. Okay,
Okay.
and WASP training, the certification is done by only Denmark, the WASP as a company. Maybe
As an
recently,
individual, as an individual, can we study at Denmark, sir? But it will be too
yeah, yeah,
expensive, right?
yeah. You should be sponsored by your company, or you can go on your own. So it's not a very long course. Okay, it will require only say one week or something maximum,
Mm.
and they will give you excellent training so that as soon as you come back, you can use it directly.
Mm.
Only thing you have to buy the WASP bundle or WASP CFD or Python WASP. Okay, this is one of the softwares. Okay, which will allow you to do the wind flow model for wind resource assessment, sighting, and you can keep your wind turbines obstacles. Okay, orography is obstacles map. Okay, what are the obstacles in the way of wind when it is coming to your wind farm? All this can
Mm.
be done using this, and you can run multiple times to get confidence. Okay, and then finally you can say this is what will be the generation from this one farm to your company.
Okay.
Okay, This is one of the softwares.
Over doing that microsighting
Yeah,
will get trained by this was right, sir?
yeah,
They should have the
you can.
knowledge and they should have this software.
Yeah, they should have the software which is licensed, number one. Okay, and you should have a hands-on training, and you should get you should yourself work with the databases.
Mm.
Then only you'll get confidence.
Mm.
But it is not a long training.
Okay.
Training is they will give you intensive training, and then they will give you support if you buy the software.
Mm.
Okay, this is one of
Yes.
the most accepted industry standard software.
Mm.
Okay,
Mm.
and then we have what is known as WindSim. This is also another very popular one. WindSim.
Mm.
It
Mm.
uses geographic information system mapping also.
Mm.
You can visualize the layers like this. Okay,
All this can be seen from the WASP or how it is, sir?
this is not from WASP. This is from WindSim, another developer.
WinSim.
Yeah,
Okay.
yeah. WASP will also have some graphic interface model, but this is not
Mm.
fundamentally. It is not CFD based. Okay, and
The
later
CFD,
on,
it's a
CFD means
CFD
computational fluid dynamics.
computation.
Computational fluid dynamics. Computational fluid dynamics. I will discuss this briefly in the afternoon.
Okay, 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 sir. Okay, okay.
Okay. Uh, so this is essentially the WASP bundle is the main thing for them. That is their breadwinning. Okay. They have many all over the world. They would have sold this. Okay. WASP CFD, how it compares with this WinSim, which is essentially based on CFD. Okay. That is, you can visualize as the wind flows through your wind farm. Okay. You can create
So
wind
we'll
farm.
have to do that WASP also. We'll have to run through this WinSim also, sir. Or this is different
It is not.
practices.
It is not necessary for every time. Okay, uh, uh, it depends on what you are comfortable with. You can use any one of them. Okay, and this also gives you all the outputs that can be obtained from WASP. Okay, then here you can load different layers. Okay, bad impact layer, uh, no go region due to political reasons. These reasons you cannot go, and you can simulate wind flow like this. Okay, the red areas may be high wind speed, the yellow areas steam speed. This may be high turbulent region in
This
the
actually
surface.
gives the historic, all the present or future data, sir.
You can it will allow you, because it is a built-in wind farm forecasting model. It will allow you to generate historical data in simulation form, as well as future data if you are proposing to keep a 3 megawatt wind turbine in a wind farm. So many of them, that
Okay.
also you can study. Okay, so you may have to give inputs in terms of either wind speed variable distribution parameters. If you give, it will take automatically simulate all this speed distribution for the site. Okay, each wind site will be characterized by wind speed distribution, right?
Yes, sir.
So that wind speed distribution, if you fit into variable distribution, there are only two parameters required. One is scale parameter, another is shape parameter. What is the shape of the bell curve, and what is the magnitude of the maximum possible wind. Okay, so C is the almost mean wind speed, K is the shape factor. These two parameters will define the wind speed distribution at any given site. Are you able to see it clearly?
Yes, sir. Yes, sir. Clear.
Okay, right. Okay, then there is one more. Uh, this is fairly little bit cheaper than uh, WindSim. Okay, WindSim. This is from DNV. This is another.
Sir.
DNV is the only worldwide known certifying body in India, in the world today. They have bought out all the small wind turbine certification bodies, and they are the only body doing certification apart from GL or UL. Okay,
Okay. GN
uh,
means?
GL was bought by GL was initially it's a GL is a German company, Germanischer Lloyd. Okay, they bought Gerhard Hassan, one company which was doing this wind farm planning. Okay, and the GL was bought by DNV now. So DNV has the full market of the wind farmer. It is wind farmer is a software, wind resource husband software from this company.
Okay.
Okay, right. These three softwares will be able to give you um, licensed software. If you use, you will be able to assess feasibility of a wind farm and a greenfield project, or how to repower a existing wind farm. Okay, you can estimate the as existing wind turbines. You can estimate the what is the power being produced, and you can compare the actual generation data if it is available, and then tell the management that if you put 3 megawatt wind turbines instead of this, you will be able to get this much of extra energy and this much of extra income. That way, you can calculate and show. Okay, using these softwares.
Okay.
Is it clear?
Yes,
Okay.
sir. Okay.
So, in conclusion, I would say wind resource drives the project viability. Main thing is wind must be available. Okay, and wind conditions are site specific and time and height dependent. Okay, and accuracy is very crucial because suppose if you have a wind site which is 6.35 meter per second.
So
Okay,
one small doubt, sir. Sorry for interruption.
சொல்லுங்க.
Only with those three softwares only, this micro sighting can be done, right, sir?
uh, yes, but intuitively experienced people can do other ways also. Okay, but
Okay.
sometimes, most of the time, the financiers, they will insist, do you have a vast output? Okay, there are
Okay.
other companies which do not use any of these software. They have their own company softwares.
That is also there.
Yeah, yeah. Vortex Corporation, Spain, 3 tier from USA. 3 tier is already having office in India. Also, 3 tier.
Mm.
Have you heard of 3 tier?
Three?
3 tier, TIER.
Three tier. No, sir.
3 tier. We can say 3 tier. It is part of one of the big companies which is involved in the renewable energy business. They do both solar and wind. That's an American-based company
Okay.
now operating in India also. Okay. Uh, so you can. There are many companies now which may not use these the three. In a new way, you have all these softwares. They can give output for any feasibility study. They can use depending on the scope defined in your project. You can have comparative results from all the three softwares. Okay, in any way. Okay, accuracy is crucial because if a if a wind speed of 6.35 at a hub height of 100 meters is changed from 6.35 to 7.11, a small shift, less than 1 meter per second shift in the wind speed can give you 50% more output generation in terms of generation. Do you get that?
Mm.
That's why accuracy of wind sighting is crucial. Wind resource assessment is very crucial. Program must be designed to maximize accuracy. Okay, and combination of measurement and modeling techniques gives a combination means various modeling, CFD modeling, digital modeling, bundle, a combination of assessment methods may give more clear modeling technique gives most reliable result, and very clearly know the uncertainties and incorporate them into decision making so that good financing terms will depend on it. Okay. In other words, in business, wind farm business, they call it bankable measurement. Okay, okay, bankable wind resource estimation.
Mm.
That means, is it done as per the IEC standard, the wind mass measurements? Is it done as per the data analytics procedures given by IEC? Okay, then it becomes a bankable measurement. Met mass based measurement is bankable measurement. Modeling based measurement is not bankable, they will say. Okay, that's why high accuracy is required for a large project development. Means better to put one met mass, at least measure for 1 year. Okay.
So when
Ah,
the project we want to install, so the
yeah,
wind must to be installed a year back to
yeah,
ascertain
yeah.
the data for a
In
particular
the
area.
in the
After
case
that
of,
only
yeah, 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 go ahead.
we can proceed with the project.
Yeah, the greenfield
That is
project.
most.
Yeah, in the greenfield project, that is the best way to go about. Okay, in a repowering project, suppose you are acquiring uh, some 50 investors in Nagargoil, RLY Mori. Okay,
Mm.
okay, they are willing to repower their wind turbines from old 150 kilowatt and all that. Okay,
Mm.
in that case, you can take the generation data and find out what is the wind resource there. Okay, you can use the generation data and the wind data available there. That can be used without putting a wind mast to assess your uh, new scope of repowered wind farm. Is it clear?
Sir.
Yeah. Yeah. Any doubt on that?
No, sir.
Because okay, that is 20 years and experience is there already.
Yeah.
For what wind speed, what how much it generated.
Get it. Yeah.
Okay. So based on the generation, you can have full confidence that this much of wind speed has been available there. Okay. So
Understood. Yes.
in such places, you don't need a met mass measurement because there will be already met mass
Yeah,
measurement
data is
available.
available.
Yeah,
Mm,
generation
generation is
also is
available.
available. Okay. Right. I think this is